Hello everyone. So in the last video we talked a lot about, well, not a lot, but uh, we were introduced to the inverse of a matrix. So inverse of a matrix, we need to have what is called the determinant, and which is so to have an inverse of a function, you just multiply both ends, subtract it. So this diagonal subtracted by the multiplication of this diagonal, and that's the determinant. And you get a constant. That constant you multiply it by each and every element within the matrix. So so that's the determinant. But you have to note something though. You've actually flipped. So you've actually flipped the D and the A, and you've actually changed the sign. Once you multiply a matrix by its inverse, commutative property stands, and you should get an identity matrix. If you are, say for example, you have this equation here. Usually, when we have a linear equation, what you used to do is you divide by a, so you have x equal to b over a, and you really can't have 1 over a with matrices, but there's no division actually. But what you can do is have an inverse. So in this case, what you would do is that you would multiply by the inverse, and you would get the identity, which is basically 1, and b multiplied by the inverse of a. And that's how you basically do it. Uh, and for the rest of the rules, where you have the identity, where you have the multi-commutative property, it actually stands. So it doesn't stand when you have the inverse. That's it. And for everything else, it still stands. It's totally valid. The commutative property has to be that. So if the a is to the left, then you should multiply a inverse by the a to the left hand side. So to the right, then it has to be to the right hand side, and this also happens to the right hand side. And you have an example here. So the inverse of this is actually 3 multiplied by 8 subtracted by 4 multiplied by 6. That's the determinant. And then you would have 8 here and 3 here and negative 4 and negative 6. In this case, the determinant is undefined, so there is no inverse for this matrix. Now, if you go back to the lesson that we stopped at, so this is called singular, in which you have the inverse is actually undefined. Now, what we want to do, what we wanted to do in the last video. So, just a quick reminder on why this is stacked on top of each other instead of it being a row, is that you basically you can't really do multiplication. So these are the number of columns. You should have 2 rows, because you have 2 columns, you should have 2 rows. But if you have a single row here, this the multiplication would not suffice and would not be valid, because you would need to multiply by stacked elements. Okay, so another what we wanted to figure out the last time was this equation here. We wanted to try to solve it using the traditional linear method equations. So this would actually be solvable using the normal method, I believe. So there's no reason for us to actually see how it works. But whatever it is, if we ever decided to, then you can use substitution. So if we can Why don't we try our Boston train example with data set up that way around? So it can be done that way. X equals B. Yeah, so basically instead of you having a single column multiplied by this matrix, you'd have done the other way around. Yeah. Okay, so I think now the inverse is easy to do it if it's 2 by 2 matrix. Let's try to do the questions first, and then where that takes us. So I have a paper and pen with me. So the inverse of this, so we have, I'm going to rewrite it down on my piece of paper. So we have 3, 5, 1, and 2. So the inverse of this would actually become, so we have, first of all, the determinant. We have 6 minus 5. That's the determinant. So you'd end up with 1. So get rid of it. And then we would have 2 and 5, then 3. Those would flip. The first diagonal would flip, and then we would have minus 1 and minus 5. The signs change for the other diagonal. So this would be my answer. Next question. What is the inverse of this function? We try not to write this on paper, just try to solve it directly. So 4 multiplied, so 7 minus 8 is negative 1. So there has to be a negative sign there. So the signs would inverse whatever the result is. So we would have 1 and 7, 1 and 7, negative 1 and 7, and positive 4 and 2. What is the inverse of this function? You would have 14 minus 12, then you have 2. And then you would have 7 and 2, negative 3, negative 4, and then you would multiply it by 1 over 2, by half. That's 3.5. It's 1.5. This is 1. This is 2. Oops, it has to be C. Alright, so what's the inverse of this function? I think I should write it down so that I wouldn't confuse the determinants again. So we have minus 15. We have minus 15 minus, so 1 over minus 15 minus that's a plus. Minus that's a plus 20. And this is the matrix. Then we would have 5 and the minus 3, and then minus 10, and then minus plus 2, sorry. So we have, we would end up with 1 over 2, or 1 over 5 multiplied by 5 vector 1. So let's try to solve this directly. So 1 over 5 multiplied by the matrix we have. So 1 over 5 multiplied by 5 is 1, and then it's a negative 2, and then a 2 out of 5, and then minus 3 out of 5. Now, I guess 2 out of 5, 3 out of 5, 6 minus, it's an A, totally. Next. So let's try to do the inverse of this matrix now, in which we have 8 minus 12, 8 plus 12, so 1 over 20, so it would be 1 over 20, and then we have the matrix of 2 and 4, and plus 3 plus 4, signs would change. So you'd have 2 over 10, so you'd have 1 over 10, and 2 over 10, 1 over 5, then we would have 3 out of 20, and then we'll have 1 over 5. We get our calculator up. We would have 1 divided by 10, that's 0.1. Do we have 0.1 in the list? No. So what if 2 divided by 20, that would give us 0.1? What is the inverse of the matrix? So we have 8 minus plus, oh yeah, that's a positive 12 minus positive 12. So negative 2, or negative 2, negative half. So negative half will be negative half. We will have negative 1, negative 2 out of 3, negative 1 half, and negative and positive 1 half. Sorry, 4, 4, 4. What is wrong with me? So it's D. Or is it? Yep, it's D. Or is the inverse of the matrix? So the determinant would be minus 8, that's minus 40 plus 40. Now 40, 24, 8, 18, oh sorry, 16. The remainder would be 16. Go for C. Which of the following matrices is singular? So what a singular means is there is no solution for it. Let's start with the first one. So we have 18, so minus 18, minus 18. It's actually a 0. There's A. Well, oh yeah, it's not it, it's this one. Because the negative signs, it's only then you would be able to subtract. This one it would be negative plus, so you would add them together with a negative sign. The Swedish should equate negative 36. Oh yeah, here is the results. Yeah, I didn't see this one. Okay. So Claire and Dale shopped at the same store. Claire bought 5 kilograms of apples and 2 kilograms of bananas and paid altogether 22. So we would have 5 plus 2 bananas would equal $22. And this is for Claire. And then we'll have for Dale 4 kilograms of apples plus 6 bananas, paid $33. Now we need to find the cost of 1 banana, 1 kilogram banana. Like what we could do is we don't know the price of apples, so that's an A, and the price of bananas, so that's a B. So we'll have, so if we try to do the equations where we have 5A plus 2B equals 22, and 4A plus 6B equals 33. Now if we try to put this in a matrix form, we would have 5 and 2, we have 4 and 6, where you multiply this by A and B, second matrix, you should be getting 22 and 33. Right. So in this case, we try to solve this matrix the way we usually do it. So we have 5, we have 5a, now in this example is pretty much similar to the example we've seen here, in which where you had, yeah, so this is it. So we could solve this problem using the inverse. So we have the matrix is ax equals b. So we could solve this using this method or using the reduced echelon form. For the sake of exercise answers, let me start with the reduced echelon form given the Gaussian elimination, given we've already we've already done a bit of it. So let's write this 5, 2, 4, 6, and then we draw the vertical line. We have 22 and 33 within the matrix. Now, if we try to do the reduced echelon form, remember that in order to reduce echelon Gaussian elimination, we should have leading ones on every row. So to suffice 1 on the first row, we should scale the first row by 1 over 5. So we should have 1 over 5, so that's a 1, 2 out of 5, and then 22 out of 5, and then 4, 6, and 33. We divide the second row by 4. Uh, I need to have a 0 below the 1. So we multiply the first row by 4 and subtract it. So we would have 1, 2 out of 5, and 22 out of 5. That's for the first row. As for the second row, we have 0 and so 2 out of 5. Let me get the calculator again. So 2 divided by 5 is 0.4. 0.4, we multiply this by 4. We'll have 1.6, so 1.6. And then we would have 33 multiplied by, sorry, so we'll have 22 divided by 5. Oops. 22 divided by 5 is 4.4. Get rid of the fractions and write it in floating points. So 4.4, we multiply that by 4. Multiply this by 4, we'd have 17.6. Now we should have a leading one for the bottom row. So let's write this down. F2 divided by 5 is 0.4. So for the first row is 1, and then 0.4, and then 4.4. For the second row we have a 0. So we'll divide the second row by 1.6. So, and that's a 1, and 17.6 divided by 1.6. That's like 11. Uh, uh, This is a national form. This is in Gaussian elimination. So if we take the second equation, the second row, so for the second row we have b. So we have b equals 11. Hmm. I've done a mistake. I've actually done a mistake in the Gaussian elimination, or in the process where I multiplied this first row by 4 and subtracted by the second row. I've only done the multiplication without the subtraction. So we should do 1.6 subtracted by 6, which took a negative 4.4, and then for 17.6 subtracted by 33, and that's 15.4. 15.4. And now we should divide the second row by negative 4.4. So when we have negative 14.4, so 15.4 divided by 4.4, we get an 11 there. How is this even possible? Now it's a 15.4, we divide that by 4 by 4, we should get 3.5, not 11, 3.5. So the banana is actually $3.5, which is a B. Now this is one solution using Gaussian elimination. Now what if we decided to opt for the inverse of the function? So it's a 2 by 2 matrix. So which is it's a 2 row in the matrix, so 2 by 2. So we could have ax equals b, and then x is the banana and apples variables that we are trying to get. So we multiply by the inverse, so x would equal b multiplied by, no, sorry, x would equal a inverse multiplied by b. Remember, if it's the left side, it has to stick on the left side. So we have that matrix of A. We have the matrix of A, which is 5 by 6. So the determinant would be 1 over. So it's 1 over 30 subtracted minus 8. So this would actually become 22. So it's 1 over 22 multiplied by 6, negative 4, negative 2, and 5. So 6 out of 22, and negative 4 out of 22, and negative 2 out of 22, and 5 out of 22. Now we'll try to solve this. We would be getting, so 6 divided by 22, we will have 0.27. 0.27 as 4. 4 divided by 22, we would have a negative of 118. And then 2 divided by 22, that should be 1 over 11. Negative 0.09. And then 5 divided by 22, we would be getting 0.227. Very close. There's the inverse. Now, if we multiply this by 22 and 33, we would be getting so 0.27 multiplied by 22 plus negative 1.8 multiplied by 33. This would give us, so 0.27 multiplied by 22 minus, and then we'd have 1.8 multiplied by 33. Very close to brackets. This gives us negative 53 point. I'm off with the numbers, but I'm sure that 3.5 is the right answer. So if we try to follow along with what he's done, we've actually done it right. So we've been getting 1 over 22, which is what he's gotten here, and then we have 6 and 5, negative 4 and 2 divided by 22, which is totally correct. This is totally right. Right. It was easier for him to multiply it by this one to get rid of it, but it really doesn't matter to make X easier. It really doesn't matter at all, because so if we try to do let's try to do 6 divided by 22 is 0.27, right? 27 multiplied by 22 is actually a 6. I'm not sure we got larger numbers there. So that's a 6. 6 minus 1.8 multiplied by 33 is 50. What is going on? I'm probably doing something wrong here. So I'm definitely doing something wrong here, and that is simply so 4 divided by, let me double check my calculations. It doesn't look right here. It's 0.111 and 18. It's not really 1.18. That's where we're getting the numbers of. So this one would deal the 6. So we would have 6 minus 6, 6 minus 6, that would be 0. So we'll have a 0 here. And no, wait a second. So 0.27 multiplied by 22, right? So 6. So it's minus minus, that's plus. So 0.18 multiplied by 33. 0.07 multiplied by 22. What am I doing wrong here? Something is a bit off. Something is not really right with my numbers. So 6 divided by 22. Okay, and then we have 4. Oops, we have 4 divided by 22. 2.18. Okay. Multiply rows by columns. So 0.27 multiplied by 22 or y plus or negative, then we would have open bracket 0.18 multiplied by 33 close bracket 0. I'm not sure what am I doing wrong here. Let's try to do 0.09 multiplied by 22, 1.98. So that's like a 2. I have 0.227 multiplied by 33. Oops. So like 7.5. So 7.5 minus 2 is 5.5. Which is not right. So you get 5.5 and 0 for the first one. What is going on? Am I doing something wrong here? So I've opted for this, I've done this, and then the inverse of this is actually that. I'm doing exactly that. Wait a second. Where is my determinant? Where is it? Please tell me that's where I'm doing wrong. So that's right, this is the inverse, I've done that right. So negative 2, negative. So I have the determinant 1 over 22. Therefore, okay, so why didn't I get the same result though? Using Gaussian elimination, I was able to solve this. But doing this approach, I'm not really trying to get any closer. So up to this point, I'm cool. Now it starts to get a bit shaky. Let me do this approach, okay? So we've got 6 and minus 2. You get a minus 4 under 5. Then 22 over 22, that's a 1. And 33 over 22. That's like what? So we have 33 divided by 22. It's like a 1.5. So 1.5. So that would be a 6 minus. So 4 multiplied by 1.5 is like 6. So 6 minus 6. What is going on? It's 0. And then it's minus 2 plus 7. That's 5. Then why am I not getting the same result? What is going on here? Let's try to do what he's doing. Let's do 1 and 1.5. Multiply by 6 minus 4 minus 2 and 5. So 1 is actually 6. 1.5 multiplied by 2 is actually 3. Interesting. What am I doing wrong? It's exactly the same as this problem here. So trying to figure it out. It's exactly the same. Like, what is wrong? 3, 3.5, and the inverse of it is actually 3.6, 3. Yeah, 3.6, 3, 3.2, 3.5, which is here 3.5, 3.2, 3.6. What have I done? Wait a second, let's compare these two, okay? I'm gonna write them down here and try to compare them together. So we have x1 and x2. There has to be something off about it. There's something about the transpose is what I was talking about. 3.6, which equals 118.4 and 135.2. Got it. This is the first method. I think it's easier just to compare these two side by side. So we've got, this is the first problem. Let's go to the second problem. We got 3. What is that? You see, this is where the trick happened. That's the bus. That's the train. Oh. Child adult bus train. That one we've got bus. So I see what we've done wrong here is that you have to line up whatever it is that you're adding. So for example, in this case, what we are adding to the x1, so row column by row, right? So 3 multiplied by x1 plus 32 multiplied by x2. So 32 here is actually hmm, I'm just confused about what makes you put what variable in which column. A child and an adult. So a child riding a bus and an adult riding a bus. In this case, we've got a 3 multiplied by the bus and by the child, and the bus multiplied by the adult. Okay, that makes sense now. I get the point. So, in this example where you have the child and an adult, you have bus and a train. So you have a column multiplied by rows. So each column you multiplied by the bus. So each child and adult through the bus and the train, the bus. And in this case, we've got columns multiplied by rows. So the columns, you would have a 3 for the bus, but that's for a child, and 3.2 for the train, for the adult. You're still doing the bus. Now the child with the bus and the adult with the bus. Child, the bus with a child, and the bus with an adult. So it's basically the same. Interesting. So let's try to do more of it. I hope we have more examples like that. Let's do another. Oh, we've done. I wish we had more. We got one wrong answer. It's really nice. I really liked it. I just hope we can reference it for maybe future. So the caption can have that. Okay, so that was an interesting one. All right, have a good time.